All right, let's talk through your questions on your end of module study guide 1. I have both versions. I have your Canvas version, and I also have the paper copy version that was available to you in class. These are almost the exact same, but a few questions have changed from the paper copy to Canvas so that we can check our answers. I'm going to try to do most of our examples off of the Canvas version. All right, so question number 1 says use the picture to answer questions 1 through 3. So we're using this picture on the first 3 questions. Number 1 says, if the original lengths are multiplied by 1/3, what are the new coordinates? We need to take each of the coordinates in our point and multiply them by 1/3. So point 1 at 0, 0, 0 times 1/3 would be 0. 0 times 1/3 would be 0. Point 2, 6 times 1/3 would be 2. And 0 times 1/3 would be 0. 6 times 1/3 would be 2. 9 times 1/3 would be 3. When you're entering your answers in on Canvas, make sure you use your parentheses and your comma in your points. Question 2 says, is the new picture an enlargement? And this is a true or false question. So if we're starting with these original points and we look at our new points and our numbers are getting smaller, then we would say that this statement is false. We could also look at our scale factor, noticing that it is less than 1, which would give us a reduction. So question 2 would be, let's find it right here, would be false. Question 3, what is the constant of proportionality? This is the number that we multiplied each of our coordinate points by in problem 1. So if we look at problem 1, we multiplied each of them by 1/3, so our constant of proportionality would be 1/3. Let's move on to question 4. Hayden likes building radio-controlled sailboats with her father. One of the sails, shaped like a right triangle, has side lengths measuring 6 inches, 8 inches, and 10 inches. To log her activity, Hayden creates and collects drawings of all the boats she and her father build together. Using the scale factor of 1/4, what would the side lengths be on the scale drawing of the sail? So they tell us in our problem that our scale factor is 1/4. So we need to take each of our original side lengths and multiply those by 1/4. So for side 1, if we do 6 times 1/4, we get 6/4. So we could enter this as 6/4. Or if we want to make that into a mixed number, it could be 1 and 2/4, which would be 1.5. Side 2, 8 times 1/4 equals 8/4. Or when we simplify 2, and side 3, 10/1 times 1/4 gives us 10/4. Or when we simplify 2, that would leave us with 2/4, which simplifies down to 1/2. All right, our next part says to use the following problem to answer questions 5 through 7. The sponsor of a 5K run walk for charity wishes to create a stamp of its billboard to commemorate the event. The sponsor uses a scale where 1 inch represents 4 feet, and the billboard is a rectangle with a width of 14 feet and a length of 48 feet. So I'm going to underline up here where it says our scale is 1 inch represents 4 feet, and the billboard has a width of 14 feet and a length of 48 feet. I've underlined those because those are the important parts and information in the question. So question 5 says, what is the constant of proportionality? Remember, you are starting at the billboard. So we're going billboard to stamp. So if I go back up here, it says 1 inch of the stamp represents 4 feet on the billboard. So 4 feet to 1 inch. So this would be my starting or my X, and my stamp would be my Y. To find my K value, we do Y divided by X, which would be 1 to 4. So 1/4, or 0.25. Question 6 says, what will the width of the stamp be? If I go back up to my problem, I notice that the width is 14 feet. So I wrote that down in my problem. We're going to multiply that times our scale factor of 1/4, which gives us 14 over 4, or when we simplify, 4 goes into 14 3 times, and that leaves us with 2/4 or 1/2, or 3 1/2. Question 7, what will the length of the stamp be? If I go back up here to the top, I know that the length is 48 feet. And we take that times our scale factor of 1/4. So we get 48 over 4, or if we simplify that, we get 12. All right, question 8. The Greenhouse Club is purchasing seed for the lawn in the school courtyard. The club needs to determine how much to buy. Unfortunately, the club meets after school and students are unable to find a custodian to unlock the door. Anthony suggests they use his school map to calculate the area that will need to be covered in seed. He measures the rectangular area on the map and finds the length to be 10 inches and the width to be 6. The map notes the scale of 1 inch representing 7 feet in the actual courtyard. What is the actual area in square feet? So we're looking at our scale, which is starting at 1 and ending at 7. So 7 over 1 would be our constant. On the picture, we know the side lengths are 10 by 6. So we need to start with finding the area of the picture. 10 times 6 is 60. And then we're going to take that area times the scale factor twice. Now remember, we do the scale factor twice because if we were to look at the side lengths, we would times this one by 7 and we would times this one by 7. So we have to do the same thing to our area. So we're going to go 60 times 7 times 7. When we do that, we get 2,940 square feet. Question 9. Eric eats 12 ounces of candy in 6 days. How many pounds of candy does he eat per day? So we're doing candy per day. So we know he eats 12 ounces, but we need this in pounds. So we're going to change 12 ounces to pounds. So 12 over 16. Which, let's simplify this. So let's divide both by 4. We get 3/4. So we're going to do his pounds of candy, 3/4, and we're going to divide that by how many days, which is 6. In order to divide our fractions, we keep, change, flip. So we're going to change those. We're going to flip the bottom, so 1/6. And now when we multiply, we get 3 over 24. And then we need to simplify 3 over 24 and divide both by 3. We get 1/8. But notice here it says to report your answer as a decimal and to not round. So when we do 1 divided by 8, we get 0.125. Question 10, error, same information. He eats 12 ounces of candy in 6 days. How many days will it take Eric to eat 1 pound of candy? So we're talking total days. Well, we know if he eats 1/8 of a pound every day, if we want this to be a whole, we would need 8, so it would take him 8 days. All right, and question 11. Joanna ran a mile in physical education class. After resting for 1 hour, her heart rate was 60 beats per minute. If her heart rate decreased by 2/5, what was her heart rate immediately after she ran the mile? This would be a great question to do our tape diagrams on. So I'm going to draw one here. My bar is going to represent her heart rate immediately after she ran the mile. So this is Joanna's heart rate. So we know from the problem that it says it decreased by 2/5. So we need to chunk our line into fifths. Yeah, it's kind of close. So if it decreased by 2/5, we would have 3/5 left. So really, I'm looking at this part right here. And we know that after she rested, it was 60 beats. So I need to take this 60 and divide it into the 3 sections. So 60 divided by 3 would be 20. So each one of these boxes is going to represent 20 beats. So if we're looking at this total of how many she did right after she ran, we would have 20, 40, 60, 80, 100.